Okay, so this session is multi-beam echo sounders and patch and performance tests. And anyone who's in here for the last session, Joe did a really nice job of describing the patch test for a LiDAR system. And this session is going to go through both the bathymetry systems, which we started out with, single, and then dual head, and then also a alternative to doing the LiDAR patch test. So we'll start out with the presentation, as usual. And this is probably my favorite picture in describing why patch tests are necessary. So what we're seeing is a riverbed at about 47 feet and surveyed in two different directions, and this is the cross section. So what we know is that there's only one riverbed down there, but when we're surveying in two different directions, we see something like this. So that's clearly an error, and that's the type of thing that we're trying to compensate for. So we're looking at angles, the roll, pitch, and yaw mounting angle of the sonar relative to the rest of the devices, and we're also looking at GPS latency. The GPS latency used to be something that we really had to keep an eye on, but nowadays with the low latency systems, it's not really an issue, and doing a latency test is really more of a reality check. So, and then this is the Army Corps of Engineers manual. I think this is probably pretty dated. I think this is maybe going back 5 or 6 years. But patch tests are performed after initial installation and periodically thereafter. So it's relatively vague on that. Okay, so one of the most important things when you're doing a patch test is to find a good location. And what we need for the roll test is an area that's reasonably flat. And along a dredge channel, it's usually pretty good. Anchorages are good. Just whatever you can find where the depth isn't changing very much. And then for the latency pitch and yaw tests, we want to look for an area where the bottom is changing quite a bit, variable terrain. And a lot of time people use the side slopes of a dredge channel as an area to do these tests. And then pipeline crossings are excellent. And we look at this section down here, and unfortunately this survey isn't included in the training notes. We've got a couple of patch tests that are, but this one didn't make it in this year, but I hope to get it in next year. So we've got everything down here. We've got the variable terrain from the pipeline. We've got the flat area around it, and this is like a perfect spot. Feel free to jump in if you have any questions. Okay, so once we've chosen area, then the second part of it is the way you run the survey lines. And there's just certain rules to it, and it has to do with the geometry of multi-beam calculations. So when we're doing a roll test, remember that's in the flat area, this AB line, and we're going to run that at normal survey speed. For the pitch test, this would be the CD line. That's where we're running over the pipeline or the slope. For the yaw test, we're using some offset survey lines, parallel offsets. Typically the separation is the depth in the area. And then lastly, for the latency test, you're running in the same direction over variable bottom, and you're going to run at high speed, at different speeds, high speed then low speed. So yeah, if you can remember all this, then it becomes relatively simple to get through the patch testing. Now, what I showed you was for a single head system. A lot of people are starting to use the dual head multi-beam systems. In that case, you have to run it a little differently. Instead of running reciprocal lines, you run kind of a serpentine pattern like this. And that's so that you have areas where your port side head overlaps with the port side and starboard with starboard. And if you run it like this, then you get that. And we've got a demo project for that one too. Laser scanner. Joe showed you in detail how he did the calibration over in England. And this is the same concept. In this case, we're using a lamp pole in a parking lot. But same idea, we're running 4 lines in a pattern going around the pole. So we're getting shots from all different directions. And we're also getting shots off the parking lot. And this shows, this is just a neat picture. It shows the pole. There was a trailer in the background, and I believe you can almost identify this as a 93 Ford Taurus or something like that. When you're doing patch testing, some things you want to avoid. If your positioning is bad, your patch test is going to be bad. So, RTK whenever possible. Avoid patch testing in very shallow water. So once again, the math of this is such that the deeper the water, the more reliable your results. So if you have the opportunity to patch test in 40 feet of water versus 100 feet of water, you're going to be better off using the 100 feet of water. And a question sometimes comes up is that should I always do the patch test in the area where I'm surveying? And that seems kind of like an obvious thing. Well, yeah, you want to patch test where you're surveying, where you're doing the survey. But I think that if there's a deeper water area outside the survey section, you'd want to do the patch test there. And I'm sure there's differing opinions on that. Peter, do you have an opinion? Okay, so Peter agrees. Once again, do your patch testing, deepest water you can reasonably find. And then this last one is something that I found over the years is, don't view the results as exact. I've seen people go out and do a single patch test and say, okay, my roll angle is 2.37 degrees. They're going to set that in there and then forget about it. And that's probably not the right way of doing it. You want to do a lot of patch testing, especially initially, and you're going to see that there's variations. It's not going to be exactly the same every time. But over time, the average is going to kind of home in on the true value. So, and once again, we're simply trying to find out where this device is pointing, in 3 different directions. So it's not really rocket science. We just want to know exactly where the device is pointing. Okay, and then the patch test processing, and I'll step away from the presentation for now, and we'll go into HYPACK. And we've got on the training thumb drive, there's a sample patch test single head. And I'm just going to start MB Max, which is where the processing is done. And in this case, we've already edited the files, so you're not going to find them in the raw folder, you find them in the edit folder. And then what we have is a log file with the entire patch test, and then we have the log file with the individual patch tests. You can do it either way. I kind of prefer to take it on one at a time. So following that, I'm going to just open this latency log file. And I don't know if you can read this, but what it says, the first one is run slow, and the second one is run fast. And you can usually identify that, and that the slow line is going to be a lot bigger. So in this case, it's almost twice as the slow file is almost twice as big as the fast one, so that's good. So we're going to select all these. Okay, the matrix, we're just going to leave the cells at 3 by 3 for now. And I don't think there's anything we need to change in here, so we're going to OK. And then since the, yes?
Just a quick question on that previous menu you had up.
Yes.
If you're using a multibeam that's got an integrated MRU, do you need to deselect, do you need to ignore role in the hardware setup while you're doing the patch test?
Okay, so the question is, if you have an integrated system with the MRU integrated with the head, do you need to ignore the roll when you're doing the patch testing? And the answer would be no, you don't need to ignore the roll. You use all the sensors. Yep. Okay, so since these files are edited, we can go directly into the stage 2. And you can see we've got just running over the edge of the channel, I think it is, or maybe an anchorage. But we've got a nice variation in depth. The shallows here and the deeper here. So at this point, there's 2 ways you can go with running the patch test. Under the Tools menu, and then Patch Test, and then Latency. Latency is always run first. So we can select that, and it brings up the patch testing cross-section. And if I get that out of the way, you can see that it made its best guess as to where it wants to cut the section. And it's just, underneath the track lines. The alternate method is to do it yourself. You just click on the tool. And there we go. We end up with pretty much the same thing. So 2 ways of doing this. Then over here, under the patch test, we've got, you select which test you're doing, and we're running GPS latency here. And then this step size, what this is, if we've got coarse, medium, and fine, and then if we look over, if we look down here, we see some values. This is angle and time, or time step, number of steps, and then this is vertical adjustment is different. So watch as I click on coarse, the step here went to 0.2, which is 200 milliseconds. And then the number of steps is 21. So we click coarse and start latency test. Okay. And then the next thing to look at is this graph over here. And what this is showing is like a cumulative error at each step. So easy to look at. Let's go step plus. And now the error is increasing. And we can see this up here, although I don't have the color coding set right. So let's just right click, color settings, color by file, apply, and close. Okay, so this is nice. You have a visual way of looking at the result. And going back to the very beginning, we know that there's only one riverbed down there, so we're trying to adjust things so that we only see one. And as we step plus, we can see all of a sudden, all right, we've got 2 of them, so something's wrong. So step minus, back to here. And now we're overlapping with the lines pretty good. Then you can go to medium steps, start test. And then we can go all the way to fine, start test. Okay. And you see now what we had when we started was a nice U-shaped error curve, and it's kind of varying a little bit here. So, the error curve is nice when it works out. If you have this U-shaped curve and you can pick the minimum error point, then, that's the ideal situation. But you don't always get that. So In this case, we're just going to do it visually. We're going to look at the cross sections. We're going to use the step plus. And then we just, we just go until we find what visually looks to be right. And in this case, it's good. It turns out at 0, which is the latency of this system. So, everything is working out fine. And like I said, most of the systems these days are very low latency. So doing this test is really more of a reality check. Sometimes you'll find things just by doing this little reality check. I was on one boat where we had the sonar was mounted forward and we had the sign wrong. And so we just couldn't get this latency test to come in. We knew it was supposed to be 0, but it was coming out at like a half a second. And eventually we found out, oh, we've got the sign wrong on the mounting offset. So it's nice to do this as a reality check. Yes?
What is on the Y scale? What's on the Y scale?
Okay, on the Y scale is like like an error term. So as you'll see, you can kind of see this. If we step forward all the way over to the side here, okay, so here the Y scale is at a maximum. And then we look at the cross section, and the difference between the two survey lines are at a maximum. So it's just a cumulative error or difference between the two survey lines. Get this back to 0. And then when you're happy with the result, you click Test OK. If you're not happy with the result, you just close this out and try something different. But we'll just say Test OK. And then we have various options here. So you can save the test to a history file. So if we click on that, what we'll see is those patch test, final offset 0, and then the time and date of the testing. So this is nice. If we continue to do this over multiple tests, it'll start building statistics. And like I say, it'll home in on the true correct value with some level of standard deviation, which should be fairly small. Close that. The other thing you can do is update the config file, and that'll put this result in your HYPACK INI, so you'll have that in the future for surveying. And the last one is you can save it to this RTF file and make a little report out of it with the graphics. Okay, so that's the latency test. Any questions on that one? Or okay. Okay, next. Yes.
Water depth for latency, you should choose the shallowest area possible because latency can be affected by pitch bias.
Okay, but isn't running the files in the same direction negate the pitch bias?
If there's a reasonable pitch bias at a couple of degrees, it will still show. If you're going into shallow water, you've got a lot less chance of seeing that pitch bias.
Okay, so Peter's point is that when you're doing the latency test in shallow water, you'd be less likely to see a pitch bias in the test. And yeah, I'd be interested in chatting about that afterwards because I'm always learning. I didn't know that one. Okay, so we've got our latency. We said test OK. So we're going to open some more files. We don't need to save this. Exit out of the catalog. And edit folder once again. And the wisdom of the order of patch testing is that you do the latency test first, you do the pitch test next for Multibeam for this, and then the roll test and then the yaw test. So I'm going to bring in the two lines for pitch, and we have a north-south line and a south to north line run over top of one another. So select these. Okay, now it's asking, do I want to use any adjustments from patch testing since starting? And I do, because that's what we're doing. We're testing, latency, yaw, pitch, and roll. So we do want to use adjustments. So we'll say yes on that. And okay. And then we go to stage 2. And so you'll see this looks very similar to what we saw before. And the difference is that with the latency test, it was 2 lines, same direction, different speed. Here we're running reciprocal lines at the same speed, survey speed. And that should isolate the pitch bias very well. Under Tools menu, patch test, oops, we've got, okay, we can select the pitch. And you can see what it did. It automatically picked the line, patch test cross-section right underneath the transducer. Or we could have, you know, if that's maybe too much data, we can select the line ourselves. We should get the same results either way. Let's go back to okay, so we're going to select the pitch test. We're going to go course adjustments, and you can see the angle and time step is 2 degrees. So this is the course setting, and start test. Didn't change anything there. The final offset is still 0, so we'll go medium, where we've got 1 degree steps. Start test. Still sticking at 0 degrees, so we'll go fine, start test. And here it wants to adjust it by negative ½ a degree. We look at the cross sections up here, this looks really good. Just changing the steps. Okay. So, you know, my thinking is that you just, you know, and I differ a little bit with Joe, where Joe likes to get everything down to the very, very best resolution possible. You know, my approach with it is to stick to, you know, a little bit less resolution, but home in on it with averaging tests over time. So I'm just going to stop right here and say, okay, negative ½ a degree is fine. Test okay, save it to the history. This is a pitch test, close, and you know, so on. All right. So we've got our pitch result, and then the next thing we're going to do is roll. So open. Roll.log. Yes. Whoops. Okay, so if we use the automatic method, patch test, roll, and see what it did. It shows a line going across survey, perpendicular to the track lines, and this is the result of that. Alternatively, you can pick your own. You can pick what looks like the flattest spot in here, which is probably what I'd do, like right there, because we want a flat area for the roll test. And then we get this result. Okay, so roll test selected, course steps, start, and then medium steps, fine steps. Okay, so we're resolving this down to 0.05 degrees. Let's say we wanted to go to a 100th of a degree. So we can do that. We can enter anything in here for step size, and we can change number of steps too. Say, let's do 51 steps and start roll test. So here's the result with that. One way of looking at it is that the correct result isn't necessarily the minimum error, but the center of this U-shaped curve. And once again, I'm not going to stress over this individual test because I know I'm going to do more of them. And it's negative 0.13 degrees. It came in as an offset. I'm going to go OK, save to history. And so here we've got a previous test, which was slightly different. And so now we're seeing the average final offset and a 95% confidence value. I'll close. And we can even, pick another section. Let's just keep these step sizes. Well, okay. 0.1 steps, 0.01 steps, and there's the result on that. So test OK, save to history, and now you can see how it's kind of homing in on a final value. Okay, so that's the roll test, and then the last one we're going to do is the latency test. So open up the files. Sorry, yeah.
Mike, I got a question for you.
Sure.
If you save it, give you an update, you can pick files every time.
Yes.
Would you go ahead and hit yes right there saying you want to use the previous deal? Or would you hit no being you update the config file?
Well, there different things, because in updating the config file, that's going to affect what happens the next time you survey. And here, we've already done the surveying, so updating the config files isn't going to affect this data that we're working on right now. So you'd do both. You'd update the config files and then, keep the last changes. Yeah.
Just a question on the order of pitch roll in your processing. I mean, I think there's some literature kind of disagrees, with, I think even in HYPACK's documentation, I think it
Yep.
so is there much of an impact in swapping the roll and pitch processing around?
I would say no, especially if you've got a nice flat area to work in, because then the roll is independent of pitch. But if your area isn't completely flat, then yeah, it's probably better to do the pitch test next. But I think you're going to do this in iterations, and in the end, you're going to come up with the correct values regardless of the order. Obviously, do latency first, and then with this, the yaw is last, and then try to do pitch and roll. But if you do roll then pitch, I don't think you're going to see a lot of difference. Okay, so we're doing the yaw test. There's parallel lines that are separated by medium water depth. Okay, so you can see it cut the line right down the middle. Core steps, medium, okay, and here it wanted to change it by 2 degrees for a final offset of 2. If we look at the cross section, this looks really good at 2 degrees. Go through the steps, you can see that it's diverging. So 2 degrees seems like a pretty good value. So test OK, save to history, and update config file. Sure, high sweep hardware. And then we're done. Okay, so that's the single head patch test. Any questions on that? The next would be the dual head. We can move forward too. And maybe we'll just step back to the PowerPoint for a second, and if there's anything that needs a little extra explaining, I can do that here. Okay, so does everyone pretty well understand how it works, what we're trying to do? We're actually calculating, you know, we take the cross sections first, and then we calculate depths in 21 times, okay, starting from the minimum angle step and going all the way through to the maximum angle step. So it's a simple numerical method, kind of brute force, and then when we're done with it, we show the error at each step, and that's what this curve is. So it's pretty straightforward once you grasp the idea of it. Yes?
What, if you remove the equipment from the board, you have to do this all over again?
That's correct. If you remove and reinstall the equipment, you should repatch test. I guess the exception would be, and this is becoming more common these days, where the manufacturers are building integrated systems. So the multi-beam and the inertial system, everything is mounted right on a, you know, in the head. So it's all in one place. So, you know, in that case, it's kind of self-calibrating. And you wouldn't necessarily have to. You'd just be double checking by patch testing a second time.
You probably still need to do the yaw, right?
Well, I mean, I guess that, well, you know, it's, I don't know, Pete, what do you find?
You should always still do the patch test. It's a compliance thing.
Right.
The one thing that it's not going to be calibrated for is really putting the GPS antenna. So if you messed up where your GPS antenna offset is, you put that incorrect in your HYPACK, and you try to patch test your own get that if you can get the spatial position.
Fair enough. We've gone through this, order and repetition, results. Okay. So let's go back to HYPACK. And we've got a project for the dual head patch test. Spacing out here. I don't know if anyone else has trouble with this, but even after 20 years of working with HYPACK, when I change projects, I always want to go up here. But that's not the place to do it. You do it down here in the project manager. So we've got sample patch test dual head. We'll open that one up. And then we'll go into MB Max editing. And once again, we've got edited files. And in this case, it hasn't been broken up into the individual tests, so we've got a single catalog. But within here, we, you know, tell which test it is. So we can start out with the latency test. Once again, even though we don't expect any latency, select those two. Stage 2 editing, and once again, this is across the bank line. And we'll just cut our cross section down the middle. And there it is. GPS latency, course, start. Medium steps, start. Okay, see, we don't have a very pronounced curve here, so we're reaching the end of our resolution. Find steps, start. Okay, so we get a result. It says 0, which is what we'd expect. And then we're just going to do some manual step plus, step minus. And we can see that 0 is a pretty good spot. One of the things that you have to watch out for and pay attention to when you're doing this test at different speeds is that you can get a you can get a settlement that will change at different speeds. So your boat will actually be riding at a different position in the water, and if that's not compensated for, it can lead to errors in here. So if we do, let's just say that test's okay, and we cut a cross section over this entire thing. So that's what this vertical adjustment is for. If you see any kind of a vertical error or bias in your data, you can come down here and change it, say 0.1, oops, start test. And you can see that that makes a tremendous difference in the results. Now we've gone to negative 550 milliseconds. So you really have to watch out for you know, a change of the boat settlement at these two different speeds. We'll change this back to 0. Start test. And now it came up with a result of negative 0.25, just to show that these tests aren't, you know, they're not perfect. Okay, so we're going to leave this at 0. Test okay, yes. Okay, so with a dual head system, you don't have to separate it out by heads when you're working on the latency, because latency is independent of the sonar. So you can test both heads at once. When you get into the roll testing or the pitch testing, you do have to pay attention. And again, it depends on how the sonar is mounted, what the mounting frame is like, how much you're going to have to separate one head versus the other. In this case, we were safe to do, we could test both heads for pitch simultaneously. So we'll just run through that. Okay, and I kind of went past this before. Here's where you can select head 1, head 2, or both heads. So for pitch, we're going to select both heads and calibrate them together. Course steps, medium steps, okay, so here's the result for the pitch test. Along the slope here, the lines are overlapping perfectly. So we're going to say test okay, and we'll save this one to the history. Okay, and then it's when we get into the roll test that we have to pay a little more attention. So remember that serpentine pattern that we ran the lines at means that we need 3 lines instead of 2, which we needed for the single head. So select the 3 lines. Okay, so we're just going to cut a cross section across this whole thing. And there's what we get. There's the 3 lines, red, green, and blue. So let's do the patch test just for head 1. And we can see, like we saw before with the serpentine pattern, that in this case, head 1, it's these 2 that are overlapping. And we don't get any overlap with the third one. And that's fine. That's what we expect to see. Let's go to roll test, course, medium. Okay, so it looks like we got a pretty good overlap there. It made an adjustment of 0.2 degrees, and then here's the final offset. So test okay, save to history. Okay, now we're going to select the second head. You can see now we get the different overlap. The second and third lines have overlapping data. So coarse, medium, fine. Okay, so we're just going to say test OK. We might want to, look at this a little bit more closely. But we can see that, things are getting bad as we make the offset smaller. So we want to go in the other direction. Now this looks like a pretty good result here. So test OK, save to history, and then we're done with that. Okay, and then the last one would be the yaw test here. So we're going to and in this case, with this mounting frame, everything rotates together, so we can test both heads together for the yaw. Everyone gets a beer. Miller time. So we're cutting our cross section, and what we see is we've only got a single line here, I think. So there we go. Okay. And there we got overlapping data. We're doing the yaw test, of course. Not seeing the second line. Okay, well, oh, I see what it is. Instead of having both heads selected, I had head one. So let's just get out of here. No, I made a mistake. And do it again. Okay, both heads. Yaw test, of course. Test OK. Save to history. Now, one thing I'll say is that I'm not a surveyor. I pretty much know enough about surveying to be dangerous. And as we go through these things, I'm giving it from the perspective of a non-surveyor. So I'm showing you how the program works and, what, how I would use it. But you have to make your own decisions on, what kind of resolution you want to go to, how you run the tests, and there's many decisions to make when you're doing this, and I'm sure everyone does it slightly differently. But this is an approach, and it shows you how the program works. So I know when Joe talks about this stuff, he goes into a lot more detail and he does better resolution, but that's because his job is to go out in the field and make sure everything is perfect for the customers. And, that's not really my job. So just an explanation. That's the dual head patch test. Any questions on that one? Are we okay on dual head? Good, okay. So the next one we've got a project for is topo, sample patch test topo. Okay, and you can see the same pattern that we saw before. We're just running lines around the light pole in the parking lot with the boat on a trailer in this case. Okay, so we're going to select all of them. calculate the laser data. Okay, and here's the result. See, I can probably set up my colors a little bit better, but I guess it doesn't matter. Okay, so as Joe said, the first thing that you want to do with this is the yaw test, because that's going to affect everything else. But instead of doing it how Joe did it, where what Joe was doing was zooming in, here's the pole, and then taking the cloud section of that. And there we can see it. I'm just going to do it with the in the same method as before with the cross sections. Okay, so here we can see we're seeing the pole from a number of different directions. Looks like we're pretty close on the yaw because the base is aligned. We're seeing it in the same location from all different directions. Well, let's just run through it. Course steps. And you can see the error curve is kind of a mess with this thing, so you can't really depend on that too much when you're doing these LiDAR patch tests. I guess the thing to remember is that the patch test was originally designed for bathymetry, and we've adapted it to work for topography with the laser scanners, but we've got really more work to do, I think, and it's on the list to improve this LiDAR system patch test. But you can see how the base is separating as the yaw changes. I'll get it back here as close as we can. We'll go medium steps. And we'll adjust it a little bit. Okay, so pretty good. And we'll go fine steps. Okay, so that's pretty good. It looks like the base is aligning, and that's what we're trying to do with the yaw, is just get the base to align. So let's say test OK. Save to history. Okay, so now we can go into that cloud window. Oops, wrong tool. Now we can go into the cloud window and kind of double check things in the three-dimensional mode. And what we can see is that, I'm not sure why this is, but we're getting a little bit of an echo on this yellow line. And I think where that's coming from, let's just close this. You can see that the line was actually run and then curves back on itself. Oops. So what we can do is we can just remove this section of the line. Delete soundings between deleted positions, and then let's just select this tool. Okay, so we remove that section of the data, hopefully. We're still seeing that second echo. So, yeah, that's what I would. Peter suggested to just, I'm just going to remove that because we don't need all four of them. Okay, so this is looking better in the cross section, and if we look at the cloud section, looking pretty good too. So we can rotate this, and now we can see the base from all different sides, and it looks like we've got it in a good spot. I don't think we can easily do a lot better than that. So the yaw test is okay. Next one we're going to do is the roll. And just going to take a cross section. And here we don't care about the pole so much. We're just trying to get the parking lot to line up. We're just looking at the backscatter from the parking lot. A roll test. Medium. Okay, there's the result there. Looks pretty good. So we'll test okay. Okay, so the last one would be the pitch test. And if we just do the cross section here, you can see that the base aligns pretty well. Well, actually, it looks like we're pretty close here with the pitch. And let's just start that course. Medium. And then we'll just change the steps. And you can see what's happening is we've got the tilt on the pole. So we're just going to step minus back. Okay, and this looks like about as good as we can get. So we'll test okay. I'll just look at it in the cloud view again. Okay, so looks like we're not perfect here yet. But we're pretty close. And that's the idea. Now, the alternative to that, what Joe was talking about, is from this cloud view here, you can actually go in to the read parameters. Oops. Devices. And then we can actually change the offsets in here. So the manual method. You know, I'm not going to do that, but that's the alternative. And what we hope to do in future versions of HYPACK is to come up with an automatic patch test that works in the cloud window. So it'll be similar to what we have in the cross sections, but it'll work in the 3 dimensions. What's that?
Are you going to license the ball site method?
I don't know that we have any. Is that what Shom is using? No.
It's used to run the LiDAR industry, and we've got Carousel implemented now.
Okay.
So they also license the ball site method.
Okay.
The third-party licensing agreement.
That is something that we haven't considered, but it sounds like it might be a good idea. Okay, so go back to the presentation. Okay, I think that's it with the patch testing. So the next thing we do is what we call performance testing, and that's you're testing your multi-beam system. You're trying to find out what kind of repeatability you can get out of it, and how that repeatability changes with beam angle. Okay, so the first part of this testing is to make what we call a reference surface. And once again, you pick a flat area, flat as you can find, and then you survey the heck out of it. And this is the pattern that's recommended. There's actually, 18 lines that you run in this grid that's 8 times water depth in the area. So so it's a straightforward survey. You just, run these lines. And then when you're done, let's see, you edit them, and let's see if I can do that. See, we're in MB Max. Go back to HYPACK and open the project. Sample performance. Okay, so we're going to go into the editor. And here's all the lines that make up the reference surface. In this case, I've got a matrix that we use for it. It's this reference.matrix, 1x1 cells. And, okay. So I'm just going in here to give an example of how you'd edit this data for the reference surface. And you can do this with the, you can do this with automatic filters. So let's come in here. Basic filters, the main thing we're going to do is cut down the swath to plus or minus 45 degrees. So we want only the most reliable data. You use this over-under filter. This is a nice one. It's pretty safe. And we'll use the matrix filter like we set it up the other day. So actions, filter all files. Okay. And this is what we come up with when we're done. You might want to do a little more editing on this, make sure that there's no outliers in here. But just briefly, the idea is to only keep the best soundings for this. And then we're going to do, and then it's going to saturate the area. One of the things you can do in this matrix view is you can show this count, and that's the number of points per cell. So in this case, we've got anything greater than 5 soundings per cell shows up in green. So that's not bad. That's pretty good saturation. When we go to save this, we can actually, okay, we're going to save to XYZ. We're going to save 1 point per cell. We're going to do the average. And we're going to require that there's 5 points, 5 soundings in a cell to save it. So this guarantees that you're getting some saturation. Save all files, and then we'll just call this ref Mike. So we've got that. So that's the first part of it, the reference surface. And once you've created this, you can use it over and over again. Okay, and this is just a little description of how you edit the data and save it so that you've got a good surface. And then the testing comes in. Go back to MBMax. Exit out of here. And then we have these check lines that were run over the reference surface. So let's just select one of them and load it up. Stage 2. Okay, color by count. Let's go by color by average. Okay, so this is the check line we ran. And we would go through, edit this, but in this case, we wouldn't cut the beam angles back to 45. We want the beam angles to go out as far as we can to find out what happens as you get out to 60, 65, 70 degrees. And then under the Tools menu, we've got Beam Angle Test. So we're going to open our reference surface. And here's the results. And because I didn't edit the data, we've got some outliers up here which are kind of messing up the graph. So I think maybe we have these check lines in edited form too. Okay, that looks better. Okay, so here's the results that we're getting. It doesn't look as good as what we've been seeing before, so I'm going to go back to our normal reference surface, tools. Which was more properly edited. And you can see that, okay, so what we're looking at here is the dots represent a 95% confidence level of repeatability. And then the X's represent a depth bias between the check lines and the reference surface. So we would expect this to be close to 0. This would just be, you know, kind of random errors, and it turns out that it is. And then this is the one that we're more interested in, is the 95% confidence limit. So you can see it's under 3/10 all the way out to, say, 65 degrees, and you know, under 4/10 across the entire swath. So that's the repeatability that you would expect. And then under the details, you can see, okay, at 45 degrees, 95% confidence is 0.24. Out to 75 degrees, I don't think we have any data. 70, same, 0.24. 0.34. So, yeah, so this is the beam angle test, and the idea is that this is, you know, give you not necessarily accuracy, but the repeatability of the system. So if you go out, if you have an area, the New York district is the best example I know of. They have a reference surface not far from the boatyard. Before they go out surveying every day, they run a pass over the reference surface and, you know, make sure everything is, you know, make sure that the results are what they expect. And this kind of repeatability to, you know, 3/10 or so. If there's something wrong with the system, it'll show up very quickly in this test. So, new for HYPACK 2019, I think, we've got the new beam angle test. And it's the same thing, except it gives a little bit more detail. So it actually shows plus and minus error. So here's the results. Again, the 95% confidence. But this is taking it out to negative 65 degrees to positive 65 degrees, whereas the other one just lumped everything all together. So this is an improvement. The graphs are an improvement. This also works with the dual head system, which our old beam angle test didn't. So this is something that new, and this is an upgrade from our old beam angle test, I guess. Okay, and then the last one in the performance testing is what we call this checkline statistics. And this allows you to do a quick comparison to a single checkline to your reference area. And then the checkline can be multi-beam, it can be single beam, you know, it can be whatever. So let's just say the project for this didn't get included, but we can make one up real quickly if I, let's see, I'm gonna open this checkline. And then let's see, under the filters, what I'm trying to do is make this look somewhat like a single beam file. So it's beam angle limits, so plus or minus 1 degree. Filter. Okay, so you can see what we've got is just the soundings underneath the track line, and then we'll save this out to XYZ all points. Let's just call this SB check. Close. Okay, so let's just get out. So say you were you did a single beam, you ran it over your reference surface. MB max. XYZ files. There it is. Okay, so we loaded it up and then just go to the checkline statistics. Okay, so the numbers that you see on this are first the mean difference, reference surface minus checkline. And you can see this is under a tenth of a foot. So that's a pretty decent result. And then the repeatability is 0.16, less than 2/10 of a foot. So these are good results. You'd see this, and then you can move on and do your single beam survey. If you want to do a multi-beam check line, that's even simpler. We just open up. Checkline statistics. Open reference surface. And here's the result. The mean difference, very small, 95% confidence, 2/10 plus, which is a pretty good result. So we'll close it and we can move on. Now you could do this with the reference surface. You could also do this with anything. So if you go out and do a multi-beam survey, you're done with it, and then you just run a single line check line across the survey. And then when you get back to the office, you process the multi-beam survey and then load up the check line and use the survey as the reference surface. So this can be used for a number of things, and those are just some examples. And oops. Okay, so this just kind of goes through in a little more detail the things that I just described to you. So any questions on any of that? I'll straight, yes. Yes. Okay, yeah, a run through on the grid convergence and how to properly apply it, sure. So that's done in the post processing. It's the raw data doesn't change by using the convergence. So let's go back to the single beam, or the single head, excuse me. Okay, let's see. The yaw lines. Okay, so we come over to the processing, and under sonar, you would choose. It's pretty straightforward. You just choose to apply the grid convergence. Prior to running the lines? Yeah, well, it's part of editing. So if you choose to work this way, using the grid convergence correction for heading, you'd always have this checked on. You'd always use it. Yep. Anything else? Because that's, yes?
Those lines would have to be very long.
The lines are.
Have to be very long for you to think about geology, the grid conversion. In other words,
Oh.
long line.
Oh, right, right. Well, that's okay, very long lines, because what we're doing in the processing is we calculate the convergence for every sounding point. So that might, that's gonna, if your lines are very long and, running in a certain orientation, the convergence might change, but it's actually calculated with every sounding point. So that's okay. And, to Benoit's point, we should have always been doing this, but we weren't. So now we are, and we didn't want to just throw the option in there and not let people know that there's a new option that's going to change the data. We have the checkbox, and you can choose it to use it or not use it. All right, well, I'm good. Thanks again for your attention, and see you later. Thank you.